Flappy Bird was one of the most difficult games to play. Well, at least for me. So I thought, why not automate it? Rather than me learning how to play this stupid, frustrating game, I thought of making the AI learn and play the game effortlessly. In fact, it was more interesting in doing the latter task. Welcome to yet another video of the AI Plays, where we are going to conquer the Flappy Bird game with our iRobot. There are two phases in this project. The first one is the game development phase, which sets up the whole game on a graphical user interface. Implementing this phase does not require any machine learning skills. It is a classical problem solving use case which involves a lot of coding. The second phase is the automation phase, where we implement an algorithm called as NEAT, which stands for Neuro Evolution of Augmenting Topologies. It is a genetic AI algorithm. It runs through different generations, and the neural network evolves and performs better through each passing generation. Let us go through the game development phase. There are different steps that are involved in this phase. But before that, we'll take a look at the images that are used in this project. We need a background to be set up on the game screen, a bird, which is the main player in this game, and the pipe, which acts as an obstacle to the bird. The whole code for this project is written in this Python file, and the config.txt is used in the next phase to implement NEAT algorithm. Now, the first step in the game development phase is to set up the background and the bird. We open our Python file, import the necessary modules and set up the game window. Then, we load the background image and display it on the game screen. We write an infinite loop to keep the program running until we exit the window. On running the Python file, you can see the game screen with the background. Now, we load the bird image, scale its dimensions and place it on the center of the screen. On running this code, you can see the bird in the middle of the screen. The next step is to handle the movements of the bird. By default, there would be some gravity that pulls the bird down automatically. The bird should be able to jump in response to a key press, in this case, the space bar. After the gravity and the bird jump is set up, we run the file and we can see that the gravity is pulling the bird down and I'm hitting the spacebar key repeatedly to keep it from going down. The next step is to set up the pipes and their movement. We load the pipe image and scale it. The pipes should be placed both at the top and bottom of the screen. The image that we have is the image of a bottom pipe. Therefore, we can flip the image upside down to get a top pipe. We write the code to generate pipes at regular intervals of time and store all of the generated pipes together. Then, we move the pipes towards the bird. When we run this file, you can see that the pipes are moving from right to left. But it gives us an illusion that the bird is moving from left to right. The next step would be to handle the collisions. The bird cannot jump away from the screen upwards, it cannot touch the land, and it also cannot touch any of the pipes. We write the code to handle these three cases. We exit the game when the bird hits any of these obstacles. The next step would be to set up the scoreboard. In this case, the score is proportional to time. Longer the bird stays in the game, higher is the score. With this, the development of the game is done. If you just want to play this game without the AI, you can stop it right here and enjoy playing your game. If you're lazy like me, the next phase is for you, the automation phase. The NEAT algorithm is indeed a neural network based algorithm. This means that we should decide on the inputs and outputs of the neural network. The bird should make a jump based on how far it is from the pipes. This is measured using three types of distances: the vertical distance from the top pipe, the horizontal distance from both the pipes, and the vertical distance from the bottom pipe. With these three distances, we will be having three values as inputs to the neural network. Based on the state of the bird at a particular instance of time, the bird has to choose whether to jump or not. Therefore, there will be two outputs, jump and no jump. The distances between the bird and the obstacles decide whether the bird has to jump or not. The next step is to set up the NEAT config. Let us open config.txt file. There are a lot of fields in this file to experiment with, but for now, we'll update the most important fields, which are the number of inputs and the number of outputs to the neural network. We set the number of inputs as 3 and the number of outputs as 2. In the next step, we have to write code to implement neat. There is a module named as neat in Python which provides us the functionalities to implement this algorithm. Before that, we have to find out the pipes which are present right in front of the bird to calculate distances between the bird and those pipes. Then we have to calculate the distances between the bird and the pipes. These distances will be given as inputs to the neural network. Then, to implement neat, we have to load the neat config file which I have shown you earlier and map it to the existing game setup. Depending upon the population size, in each generation, a number of birds and neural networks will be created and mapped with each other. We also remove the code where the game takes the user inputs because the user has nothing to do with playing the game now. The user inputs will be replaced with the outputs of the neural network, which tells us if the bird has to jump or not. Each generation runs as long as there is at least one bird alive in the whole population. Also, each neural network has to be rewarded based on its performance. In this case, the performance is nothing but the score of the bird. Therefore, at a particular instance of time, the score of the bird is given as fitness value to the neural network. In this way, the score of a bird in the population judges the performance of its neural network. With this, the automation phase would be completed, and the final step would be to run the code and sit back and relax while the iRobot plays the game for you. The link to the GitHub repository where the code for this project is present is given in the video description. Please go through the link and try to implement this project on your own.